Hello, Stats 300. This is Professor Gonzalez, and by now I hope you had the chance, excuse me, to take a look at the lectures, some of them, and tried some of the problems. This particular problem here is, or set of problems really, is Alex problems with the green box, and it comes from the homework 7.1. I'd like to do some of these things for you. This is kind of the next phase that I wanted to do is work out some homework problems. So this first question, it's given us the following figure is a probability density curve that represents the grade point average GPA of the graduating seniors at a large university. Okay, so now our first question, let's see if I can slide this down a little bit. It says find the proportion of seniors whose GPA is between 3.4 and 3.6. Well, between 3.4 and 3.6 is right there, and we're this whole idea back with 7.1 with the density curve. What it's talking about is that the area under this curve, right? If we looked at the total area under this curve, it would equal 1. Now, if we're trying to figure out the proportion of seniors whose GPA is between 3.4 and 3.6, that is actually going to be the area that's under that curve. And so that area under that curve is already given to us. And so the answer to this question, what's the proportion of seniors whose GPA is between 3.4 and 3.6 is 0.27 or 27 hundredths. Also can be thought of as 27%. So what's the probability? So that's the other way we can think about this area under the curve as being proportion, or we could also think of the area under the curve being the probability. What's the probability that a randomly chosen senior will have a GPA greater than 3.6? Well, let me go with another color here. Greater than 3.6, well, that's going to be this interval. And so that's going to have to be this bit right here, so that area under the curve that's in red. So what we'd want to do is we'd want to essentially take 1. Let's see if I can go back to black. I want to take the value of 1 because the area under the full curve is 1, and we would want to subtract out 0.66. Right, subtract out 0.66, subtract out 0.27 right here. And that would leave us, change my color. We subtract those out from 1. Of course, it's like $1 minus 66 cents minus 27 cents. It would leave us with 0.07 rather, which is like 7 hundredths or 7 cents if you want to think about it like that. So the answer is 7 hundredths or 7%. Okay, let's move on to question number 2. And question number 2, find each of the shaded areas under the standard normal curve. Now, standard normal curve is a curve where the mean will always be equal to 0, along with the median and mode, by the way. But the mean is equal to 0, and to the left of 0 is going to be negative values, and to the right of 0 we're going to have these positive values. Okay, and by the way, these are z-scores. So essentially these are these z-scores. Boy, I have a hard time making a z. And writing with this pencil. Anyways, these are z-scores. And so what we can do is we could look up this z-score, negative 2.52, on our z-score table or z-table. Remember, the z-table always gives us the area to the left of the number that we are looking up. Well, this is perfect because this wants the area that's shaded to the left, and that is to the left. So now we go to our z-table. Remember, the number is negative 2.52. negative 2.52, and down here I've got my z-table. Now this is the positive side, right, because it's on the right of 0. I want the negative side, so that's going to be this one. Negative 2.52, right? Negative 2. Oh, now I forgot. What is? I think it was negative 2.52 is what I'm looking up. Negative 2.52 is correct. Okay. So what I want to do is I want to look up negative 2.5. So negative, here's negative 2, negative 2.5 is in this row. And negative 2.52 is going to be in this column. So if we look down to here, oh, it's supposed to pop straight. Okay, and then negative, and then we look horizontally this way, and we can see our number, which I'm having a hard time seeing now. Oh, that's great. The whole thing just took off on me. Do that again. So if I look at negative 2.5, and I can complete the number with 2.52, this gives me the area to the left of negative 2.52, and that area is 0.0059. 0.0059. So when I go up here, so this area that's shaded right here has that area is not, it's very small, 0.0059. Okay, now what happens, excuse me, when we want to try to find the area and it's shaded to the right? Okay, if it's shaded to the right, in this case, like this right here, it's not going to be perfect for our z-table because our z-table always gives us area to the left of this number. Remember, this is a standard normal curve, so once again, that mu or mean is 0, and we want to find the area to the right of, area to the right of 2.11. Okay, well, let's see what happens. Let's go down here to 2.11. So there's positive now, 2.11, and there's 1 right there. So if we go, say 2 this way, and then 2.11, puts us right there. So what's that number? 0.9826. 0.9826. So 0.9826 is actually the area to the left, right? All this red area to the left of 2.11, but we want 2.11. So what we want to do is we want to take 0.9826 and I want to subtract that from 1. So 1 minus 0.9826, that will give me this area to the right, which that happens to be 0.0174. And that's my answer. Okay, this thing's kind of wigging out on me a little bit here. Let's see if I can move on here. Okay, so that's an example of finding area to the left, finding area shaded to the right. What else do we have? How about finding area in between? Okay, so this gets a little bit tougher in the way that, remember so let's say we were to find, let me try to change colors. Say we were to look this up on our z-score table. That's going to give me the area right there. But I want the shaded area, okay? And also if I look up that z-score on the z table, that's going to give me, remember, that's going to give me this area from this point all the way down to the left-hand side of the curve, which is not the shaded area. So let's start off by getting the green, the area that's shaded in green first. Let's do that. Let me go to my green. Okay, I think it was that green. And negative 2.48 is the number we're looking for. Negative 2.48. Negative 2.48. Get rid of that. Negative 2. Oops, this is positive. Oh boy. Negative 2.48. So negative 2.4, and then 8 is right there. That is a small number, 0.0066. 0.0066. Okay, now if I look up this number in red here, which is negative 0.58 on the z table, negative 0.58. Negative 0.58, let me get rid of that. So negative 0.5 is right here, negative 0.5, and 8 is right there. So negative 0.58 is going to give me that guy, which is 0.2810, 0.2810, 0.2810. Okay, now to get this shaded region, essentially what we need to do is we need to take this red area. Now we're not talking about the z-scores anymore, like negative 0.58 or negative 2.48. We're talking about the area. So the area that comes from the red is 0.2810. We want to subtract out the green, which was, oh my gosh. Okay, I'm going a little crazy here. The green, oh man, the green, which is 0.0066. And when I subtract all those out, you know, I like using color, and this is not very natural here. So the red minus the green is going to give me the gray, this gray stuff, right? If we subtract the two, the red minus the green is going to give me 0.2744. And that is the answer. So taking a look at the next one, you know, they want us to find the area of the shaded region, so we're going to have to add the area of these two regions, right? But we're gonna have to find the area of the two regions separately first and then add them together. Let's do the hard one first. The hard one is definitely gonna be this shaded region over here because, whoops, gosh, I'm not good at this at all. Keep on turning this into an eraser, but this is gonna be tougher because, why? Because it's shaded to the right, and our table gives us answers shaded to the left of our z-score. So let's do this one first. It's going to be tougher for sure. And let me use some color again. So essentially what I'm going to do is I'm going to find the area of almost this whole area under the curve, because that's to the left of this 2.18. Let's go check that out. So I've got to go to my table, 2.18. 2.18. There is 2.1 and there's 8. So 2.18 is quite a bit of the area, 0.9854. 0.9854. Okay, so what are we going to do to find this little shaded bit to the right? Well, of course, as we said before, we're going to have to take 1 minus that major 98, more than 98%, 0.9854, and we subtract, and that gives us the area of that little bit on the right, which is 0.0146. Now we're going to go for the easier area, and the easier area is going to be looking at this number, because naturally, when we look up this number, it's going to give us on the table the area to the left of that number, which is what we're looking for right here, right? So when I look up negative 0.33, look up negative 0.33, negative point, whoops, where am I at? Negative point, there's negative 0.3 and then 3. Negative 0.33 gives me 0.3707. 0.3707. Remember, once again, these are areas. So the area of this green is there. The area of this black. Oh, what the heck was that? Just jumped on me. The area of the black. Oh, I need to do this, I think. The area of the black is this. And so they want the sum of those two areas. So we just add them up. Add the green. Oh, I'm in eraser mode. Add the green plus the black. Let's write it down. Darn, this thing, if I tap it barely, it goes to eraser. So we've got 0.3707. We need to add that to the area of the black, 0.146. When we add it all up, we get a grand total of 0.3853. And that is the area of those two shaded regions summed up. Okay, question number 3A. Find the area under the standard normal curve to the left of a z-score of 0.56. Now, a picture is worth 1,000 words in my opinion, and so what I would do on this is I would draw a picture. Let's see if I can maybe zoom in. Nah, that's probably not going to work out because I'm going to need to go to my z-score table. But anyhow, so, we've got the standard normal curve, bell-shaped curve. You can still see I'm drinking lots of coffee. Look at that shakiness. Anyhow, now right, every single time in the standard normal curve, there's the mean. Now this z-score is 0.56. That means it's to the right, so I'm gonna go about there, but because it's so close, I don't have a lot of space to work here. But 0.56. Oh, getting sloppy, and we want the area to the area to the left, which actually is a great thing, because if it is the area to the left, that's going to match up perfectly with my z-table. So, positive 0.56, I just look that up. 0.56, go to the positive. So there's 0.56. That gives me 0.7123. 0.7123. 0.7123. And that is the area to the left of 0.56. Okay, let's do one more of these. You got 4 to practice, but anyhow, let's do one on the negative side. In fact, let's do this one right here. Now, we know this number is, let's do, I'm back to eraser mode. There we go. Let's do part 4 of this, because you can see, what do you expect? If you have a z-score of negative 2.43, and thinking about the empirical rule, remember how much that includes if you're at 2 or 3, a negative 2.43 if you're trying to find the area to the left of that, that's going to be a very, very small area. Let's see if I can do a standard normal curve. I always like to put in my mean and a negative, that's way down there, negative 2.43. And we're just trying to figure out this little area right there. It's going to be a small number. Let's look it up, negative 2.43. Negative 2.4 can be right there. Negative 2.4 and then 3. And that area is 0.0075. Oh boy, 0.0075. Which, right, if you move the decimal point over 2 points to the right, that's not even 1%. So that is a very, very small amount of the area that's under the curve. All right, let's take a look at number 4, part 1. Now this is asking for the area to the right and to the right of 2.07. Now we should be thinking this through. We're going to for sure draw a picture. But I'm thinking if it's area to the right of that, this can be is this number going to be a small area close to 0, or is it going to be a large area close to 1? Well, I think it's going to be a pretty small area, but let's see. Let's take a look at what this picture would look like. Okay, of course. The mean, 3 is almost all of the data, right? 3 is way out here. But 2.07, that's pretty far out there as well. 2.07. We want the area to the right of that. Well, area to the right of that is going to be a small number, something closer to 0, not close to 1. Remember, if we were at the halfway mark, that would be 0.5, right? Halfway mark, the mean is going to be at 0.5. But this is quite a bit further. In fact, my drawing is probably not to scale. I think it's a smaller amount than that. So we want to find the area to the right. Unfortunately, our z-score table will give us that area if we put that number in it, which is not what I want. I want area to the right, not to the left. So I'm going to have to use subtraction, as you probably know by now. Let's take a look at the table. 2.07. So I go down to a positive 2.07, which is this table. I got to clean house a little bit here. I got stuff all over the place. Okay, so we need to go to, what was that? 2.07. Come on, 2.07. And my glasses, there's 2.07. 2.07, that's going to be right there, which is 0.9808, 0.9808, 0.9808, which is, essentially 98% of that data. So if I want the shaded region, I'm going to have to take this value, 0.9808, subtract it from, so 1 minus that, which which problem are we on here? We're on number 4. When we subtract that out, that should give us 0.0192. So there is the answer for number 4, part 1, right there. Okay. So here we're ready for number 5. Let's do part 2, since I have a little bit of space to work here. And once again, picture. So it says the areas of the interval lies between these z-scores. And notice these two z-scores are negative, which means both numbers are going to be to the left of the mean of 0. So it's going to get a little tight on my drawing, so I'm probably not going to draw it to scale. there's our mean right there. And yeah, I'm not going to be able to draw it to scale probably because it's going to be so tight right here. But a negative 0.96 will go there. And a negative, let's write about here, negative 0.76. So we want to find the area of the interval that lies between these two. So we want this area right here. Okay. Well, this takes a little bit of thinking ahead here because, well, first of all, z-score table that we have will always give us area to the left. So let's start off with, I guess, the easier one in some ways. And that's going to be, well, we need to find the area to the left of negative 0.96. Negative 0.96. So negative 0.9 and 6. Gives us area of 0.1685. 0.1685. Where am I at? There we go. Okay, so 0.1685, and then what we need is we need to now figure out the area that's given from this z-score of negative 0.76. Of course, that is going to get us from that point all the way down too far, past the shaded region. So we're going to have to do some subtraction. But I need to look up a negative 0.76. Let me look that up. Negative 0.76. Negative 0.76, negative 0.76. That's 0.2236. 0.2236. So, in order for us to get the shaded gray-black area, we need to take the larger area. Now, notice these areas are not going to be negative. Like sometimes students, they see all these negative numbers and they're expecting area to be negative. Areas cannot be negative. Area will always be positive. The z-scores that are to the left of 0 will be negative, and z-scores to the right of 0 will be positive. But the areas up under the curve, the areas under this curve will always be positive. So we've got the area to the left of negative 0.76, which is 0.2236. And we need to subtract out, I don't know why I have to make that a different color, but whatever. Some issues I have, I guess. Anyway, so then subtract that from the smaller area, 0.1685. And that is going to give us the resulting area in between those two z-scores to be, when we subtract them, 0.0551. And that is going to be the area between a z-score of negative 0.96 and negative 0.76. Okay, let's do one more, just because setting these up can be a little bit, I don't know, maybe challenging, something new. So let's do which one? Let's do number 4. And I'm going to go ahead and draw down here, since I've got a little more space down here. Okay, we're looking for the area between a z-score of negative 1.71. Okay, once again, 0. Negative 1.71 is way out here. And even further to the right is positive 2.01. We want this shaded region. Okay, I'm anticipating this to be close to 1, right? This is going to be a big amount of the data, almost all of it, right? So it should be close to 1 or 100%. It can't be exactly that, right? And it's not going to be, I mean, it should be a big number is what we're expecting. Something closer to 1, not closer to 0, I should say. Okay, so maybe the easiest way to start off is, let's find the area. Because the z-score always gives us area to the left. We're going to do this one first. Negative 1.71, and I looked that up already, and that gives us 0.0436. And then we go ahead and figure out the area by looking on the z table of positive 2.01. That's going to give us all of this area all the way, whoops, that thing did something strange, all the way down. And so that's too much, but anyhow, the result of that is going to be 0.9778. Of course, that's going to be close to 1, right? So now, if we want the shaded region, we're going to have to take, come on, it's an eraser, there we go. We're going to need, oops, I need space for that last problem over there. Let me move down a little bit. Okay. So we take the larger area, which is the 0.9778, and subtract it from the smaller green area, which happens to be, oops, I grabbed the wrong green, that's fine, 0.0436, and that's going to result, when we subtract the two, in an answer of 0.9342, which is that guy, right? And that's about 93% of the data, so that is a good chunk of the data, right? The majority by far. And let's see, let's also go for this last question, which is number 6. And number 6 kind of turns everything on its head, I guess. So far, what we've been doing is we've been given z-scores, and we look, well, let me go to the table. We've been given z-scores, either they're positive or negative. Now we know this is positive because the z is to the right. Okay, so we know that's z is to the right of 0, that's positive. These are all positive z-scores. And by the way, when your z is to the right of 0, right, at 0, right, let's take a look at that. At 0, a z-score of 0, to the left of that is going to be 50% of your data. That makes sense. So if you have z-scores to the right of 0, positive z-scores, they have to be greater than 50%, so bigger than 0.5. And likewise, if you're looking at negative z-scores, once again, if we take a look way down here, there's no negative 0. But anyways, if you looked at 0, which is at the mean, that's going to be 0.5, half the data, because the mean, whoops, there goes my phone. There's the mean right there. But if you have a z-score that's negative, well, then that area must be smaller than 0.5, right? All right, what was I doing? Okay, yeah, so what we've been doing is we've been looking at z-scores, which are these scores on the outside, right? So these are the z-scores out here, and we're using 1.4, and to get to the hundredths, we have to go up here to take a look at these different values up here, right? To figure out the hundredths. Let me erase that, it's getting messy. But the change here on this particular problem, the change here is that on this particular problem on number 6, they're asking us to say, hey, I'm going to give you an area, which is, right, area comes from the body of this chart. And I want to give you the area. So let's say they said, hey, okay, I want an area of, something's going on with this thing. It's popping back and forth. Okay, so let's say they said, hey, I'm going to give you an area of 0.9591. What z-score goes with that? Well, you have to go backwards, right? Backwards. This is different than what we've been doing. So far, we've been going from the z-score and then, right, finding that area. But this particular problem that's coming up is going to go backwards. It's going to give us the area. Then we have to go backwards, and we look at 1.7 and then 400, so that would be a z-score of 1.74. So that's the idea of this problem coming up. It's different than all the other ones because they're giving us area, which is in the body of the problem. And we're going to the outer edge to get the z-score. All right, let's see what happens. Okay, get rid of that. And where's that problem? Oh, texting like crazy. The phone is blowing up. No, not really. Anyhow, so number 6 says, use use this normal distribution. So use the use the z-score table. Let's see, to find a z-score for which the area to the left, that's important, is 0.94. Now, let's think about that. If the area to the left is 0.94, that would be 94%. That is going to be most of the area under the curve. So is that going to be a positive z-score or negative z-score? Well, a z-score of 0 is going to be 0.5. So to get bigger than 0, you have to go to the right, which is it's going to be a positive z-score to get a bigger area. Let's check that out. A z-score of 0.94. And you can see here's my positive z. And, basically I'm trying to get way out here to 94% of the data. And the question mark is what z-score goes with that. So we've got to look at the body of this chart and try to get as close to 94 as we can, 0.94 rather. And I see there's 0.9406 and 0.9418. So 0.9406 is the closest. So, okay, so this is the area, 0.9406. So we've got to go out to figure out what z-score that goes with. And that is going to be 1.5. Of course, the 100th is found by that column 6. So the z-score that is associated with an area of approximately 0.94 is 1.56. So up here, the answer is, z equals 0.56. I hope that helped, and I will do more of these. I'm still trying to figure out the best way to collect them somewhere. So far, using YouTube. I know everybody can get to YouTube, and so that's why I've been using that. And I'm looking at different files. Some files are MP3s and QuickTime files, and I don't know if everybody has those on their computer. So I've been just shooting or giving you guys links to go to YouTube. I created a channel, which is pretty crazy. I'm now a vlogger, and I created a channel, but that's so I know everybody can use YouTube. I know everybody's computer will play well with YouTube. So that's why I'm doing it that way. And I'm still learning. Anyhow, take care. I hope this helped. I will give you more of these, and we'll see you next time.